All right, honor students, let's do our chord power theorems. So we have three of them. First one, it says chords Vn and Ls intersect at point E inside the circle. It's not at the center. Center is O. So what our theorem tells us is that this segment times this segment is going to be equal to this segment times this segment. So you just multiply the two parts together. Pretty straightforward, nothing too complicated there. If we have a secant and a tangent, what we do with the tangent, we square this side, and it'll equal the product of this whole segment and then just the outside part. So multiply those two together. Then the secant segment, same idea as what you just did, but you just do it twice. So again, it's the whole segment times the outside part equals the whole segment times the outside part. So you got to make sure you do the whole segment, PB and PD, times the outside part. Let's try some of these problems here. Find the radius of circle P. Obviously, we want this segment. So this is our secant segment power theorem. So 6 times the whole thing, 10. 5 times the whole thing, 5p. Multiply. Subtract 25 from both sides. P equals 7, but that's this whole segment. So we have to cut that in half because we want the radius, so our radius is 0.5. So that's our tangent, or our secant power theorem. Here, we got our tangent secant. So it is going to be R. No idea why that went like that. We went R squared equals PR, the whole secant, times the outside part, QR. So we'll just do one of these. We'll do letter A. So R squared equals PR, which we don't know, so that'll be X, times the outside part, which is QR. So not real difficult. 105x, divide by 5, x equals 20, and 20 was our whole segment, PR, that's 20. Pretty straightforward. And now we have our last theorem that we didn't talk about, our chord power theorem. So it's E times EB equals DE times E. Very straightforward, nothing crazy going on here. So in this first one, we got AE at 6.4 times EB. Well, we don't know that, but we do need to know all of AB. So if AB is 8.9, AE is 6.4, we subtract it, and we get 2.5. Equals DE, which we don't know, times EC, or CE, which we do know. So we need to multiply those. I need to get my calculator. So 6.4 times 2.5, nice round 16. 1.6x, 1.6. X equals 10. What is it? What was X? That would be. So secant, those are our three examples of these theorems. They're not very crazy. We just need to make sure we include the whole secant segment. Tangent isn't too bad. The chords aren't too bad, but it's the whole secant. So for instance here, we could label this with letters, I suppose, if we wanted to, but we don't need to. It's 6 times the whole thing, 10, equals x times the whole thing, x plus 7. So 60 equals x squared plus 7x. Uh-oh. We got x squared, so we have to have two answers. So subtract both sides. Kind of flip it over to the other side. And then I want to factor. So I'm looking for two numbers that multiply to negative 60 but add up to 7. 12 minus 5. We find both of our x values, so x has to equal negative 12 or x equals 5. Generally speaking, we can have a negative answer for x, but in this case, x is a length of a segment, so it can only be 5, it can't be negative. So you have to double check for those.